Welcome back, everyone. Today we're going to take a look at properties of logarithms. So you already know a little bit about logarithms. You can swoop them out, you can rewrite them, you can evaluate them. Today we're going to be combining more than one logarithmic expression. And logarithms follow the rules of properties. So what I mean by that is if we had x squared times x to the third, you would leave the base alone, but you would add the powers. Logarithms are the same way. If you're multiplying, so on this side you can see we're multiplying u times v, you add the logarithms. Or you can go the other way. If you're adding the logarithms, you turn it into multiplying. With powers, if you are dividing, you would subtract. So 10 minus 7, this would be x to the third. So same thing with logarithms. If it's a division problem over here, you can see we end up subtracting. Or if you know you're subtracting, that turns it into a fraction. Now this one's a little bit different because there's only one word logarithm, right? So there's only one, doesn't matter which side you look at, there's only one logarithm. So the others had more than one. With this, you can see we have a power. And what happens is the power gets brought down out in front. So that's where the power will go. And we'll go through each of these more than once. So we're just bringing this power down out in front, and that turns into a little multiplication problem. These are kind of made up. The log of 3 equals 0.477. I don't really know if that's true or not. We're just using that to sort of practice the rules with some arithmetic. So this is a division problem, as you can see. 3 divided by 7. Order matters, we have to do top minus bottom. So since it's dividing, this would be the log of 3 minus the log of 7. Well, we know what these things are. So we're looking at taking out the log of 3, and we put in 0.477 minus the log of 7, which is 0.845. Now this is just a subtracting problem. Put it in the calculator or subtract it without it, and you get negative 0.368. Subtract that without the calculator. Who am I fooling? No one. So the idea is we can turn 21 into some expression that involves 3 times 7. Because right now the 3 and the 7 are not obvious. So I would say 21 is 3 times 7. Well, when you multiply, you end up adding. So this is really the log of 3 plus the log of 7. So the word log goes with each part. That's what we saw here, top and bottom, and that's what we see here. We're not really distributing the word log, we're just putting the log with each piece of the problem. Well, the log of 3 is 0.477 plus the log of 7, 0.845, and of course we're just going to add these pieces together, and you get 1.322. So 49. I can't write that as 3 times anything, but 49 is really 7 squared. Turns out with powers, anything goes. You can use any power. We don't have to use the powers that we were given. We have to use a 3 and a 7 somewhere, but the power can be anything because the power isn't going to be a logarithm. So this is really the log of 7 squared. So we just rewrote 49. So the power rule says, hey, you know what? Bring this power down out in front and multiply it. So this is 2 times the log of 7. Well, I know what the log of 7 is. The log of 7 is 0.845. And now we just take 2 times 0.845, and we get 1.690. So all we're really doing is manipulating these logarithms, just moving stuff around, right? So that's all this is. The idea is that when you have the word log written in more than one spot, right, like this, we have it 2 times. The goal is to not have it written that many times. We want it to be log of something. That's it. So it says to rewrite it as a single logarithm, which is the goal is to have the word log written only once. Well, subtracting means divide. And you go first divided by second. And that, my friends, is it. It's just that simple. I don't know what that is. We don't have any values to plug in. You can't put it in the calculator. So we're done. You're just trying to write it as a single logarithm. We're not trying to do anything else to it. So now when we have this number out in front, that's really a power. So this is really the log of x squared. Doesn't go with the y, just the x, plus the log of y. So adding really means multiplying. So we're going to have the word log written once, and then x squared times y. All right, so now we're going to actually determine some answers. I know you're excited. So we're going to smush it together. Adding really means multiplying. So we get log, and then 2 times 5 is really a 10. Now remember what this is. It's not there. Log with no base is really base 10. Also what's not there is equals the x. You know, with logarithms, they don't have to write any of that. So now we can swoop it out. So 10 to the what power is equal to 10. 10 to the what power is equal to 10. Well, of course, 10 to the first power is 10. So the rules are, the steps, that's the word I was trying to think of. Smush it back together. So we'll do 5,000 divided by 5. Well, you can do that without a calculator. So we're looking for the log of 1,000. Okay, again, remember, all of our tricks, no log, this is a common log. Base 10 is there. The equals x is also there, but not really there unless you write it. Because you're writing the problem, you got to write that if you want it there. So 10 to the what power is 1,000. With this kind of a problem, we're counting zeros. Just like we counted zeros over here, right? We counted zeros on this one. 10 to the what power? Well, that has 1 0. So 10 to the 1, 2, 3, 0. So x equals 3. Let's put this one back together. So this is really log of 5 squared. And we know we're going to multiply, so times 4. All right, so 5 squared is 25, and 25 times 4. We're looking at the log of 100. So this is base 10 equals x. So 10 to the what power is equal to 100. Well, again, we're counting zeros, so 10 squared. Or there are 2 zeros there. Ooh, this one looks scary. This 2 goes with the 3. So we have the log of 1 over 900 times 3 squared, right? Because that's, we can write it as a single log. So this is the log of 1 over 900 times 9 over 1. You can reduce this diagonally. We do not cross multiply. Do not. Straight across here, straight across here. So now we get the log of 1 over 100. Well, this is really log of 1 over 10 squared. And if you have a fraction, in order to bring this up to the bottom, from the bottom up to the top, you make it a negative exponent. So this is log of 10 to the negative second. So 10 to the what power is equal to 10 to the negative second. 10 to the what power is equal to 10 to the negative second. Well, negative 2, of course. All right, bases match, and we look at the powers. Now we're going to expand these, meaning messy. Make it messy. Some guidelines. However many different things you have is how many times you should have the logarithm written. So when I look at this, I see a 5, an x, and a y. I see 3 different things, which means I should have the log written 3 times. So we're multiplying all this. So we have the log of 5, multiplying is adding, plus log of x, plus log of y to the 4th. Your last step would be to take care of any powers. This 4 only goes with that little piece right there. So log of 5 plus log of x plus 4 log y. 2 things, an x and a y. So we're going to start with the log of x. Divide means subtract. Log y to the 3rd. Power comes in front of just that one piece, so the log of x has no power, so it's just log of x minus 3 times the log of y. Done. Ooh, it's a long one. We've got 7, x, 2, y. We've got 4 things. I'm going to take care of the division first. So we have log of 7x minus the log of 2y. Let's try to flatten this thing out a little bit. Ooh, now I have 2 multiplication problems. Log of 7 plus the log of x minus all of this. The log of 2 plus the log of y. Be careful. Minus. We've got to have negative in front of all of these things. So we have log of 7 plus the log of x minus the log of 2 minus the log of y. Here are the rules. If whatever you have is in the denominator, those things better have a negative in front of them, because the negative is really a power, and that's what shoves them to the bottom. So if you look at like this guy up here, right? The only thing in the bottom is y to the third, and that's the only thing with a negative sign in front of it. So we have two things in our denominator, a 2 and a y, and they each need their own negative. So if you don't distribute the negative sign, it doesn't appear as though those would be in the denominator. So you got to be careful with that one. That's a little bit tricky. Try the homework. I'm sure you're going to love it.